Okay, hi everyone, welcome back to yet another contest screencast. Today I will be attempting Codeforces round 758. This is a Div1 plus Div2 round and it is of 2 hours. So mostly the Div1 plus Div2 rounds are of 2.5 hours, but surprisingly this one is of 2 hours. So let's see if there are some changes, some major changes that we can see in this round compared to the normal Div1 plus Div2 rounds. Okay. Also the scoring distribution is kind of weird, like this one is just 250. The first problem is just 250 points, the second one is 750 points. Okay. So I guess the first problem should be very easy according to this point distribution. Should take around 1 to 2 minutes, I guess, if that is how the points are distributed. And let's just hope that we get 4 problems. That would be a good target, I guess, for this round. And we have another 30 seconds to go. Let me just see if it is getting recorded and everything's fine. Okay, looks like this seems fine as well. Let's just define this part, because this is something that is almost like common in every round. Like you do have test cases. So yeah, cool. Right. Also, this channel is pretty close to 20k subscribers. I guess by the time I upload this video, we will reach 20k. So yeah, I can thank you all in advance here. Given n, find any array of integers such that all of the following conditions are valid. Okay. AI isn't divisible by AI minus 1. Okay. So we just need 1000 numbers. Okay. How about just print, 1000 primes here, right? Okay, let's have 10 to the power 5 only. Okay, this seems good enough. Let's submit this. Okay, this one was an easy problem. We can just print out all the prime numbers. So I guess that is why this problem was, given such less points. You're given 3 integers n, a and b. Determine if there exists a permutation p1, p2, so on up till pn of integers from 1 to n. Okay, such that there are exactly a integers I from 2 to n minus 1, such that p, okay, there are exactly a integers I with I being between 2 and n minus 1, such that p of I minus 1 is kind of, okay, p of I minus 1 is less than p of I and p of I is greater than p of I plus 1. So that is like a peak here, local maximums. And then there are exactly b. If such permutation exists, find any such permutation. Okay. Cool. So we want A and B. Okay. Exactly A integers. Fine. So how about we start constructing this with peaks? Like if we go from peaks, then like let's say I have 1 and then I have 3, then I have 2, then I have 4, then I have 5. Sorry, then I have 5, then I have 4. What happens by this is that I'm creating peaks and I'm creating valleys as well by doing so. Okay. Now it depends on what do we want more. Like do we want more valleys or do we want more peaks? Okay, so if I put it like this, then I have 1, then let's say I have 3, then I have 2, then I have 5, and then I have 4. What happens by this is that this is a peak, and this is a valley, right? So then again I can sort of increase it here, 6 like this, and then this is a valley here. So let's just put a valley like this. So here I have 2 peaks and 2 valleys. This is something that can be constructed. Let's say I wanted 3 peaks. Can I have 3 peaks? For 3 peaks I need how many integers? Okay, Like if I want 3 peaks, then I have 3, 5, and then I have 6. So I need to have some integers here, right? So in order to have 3 peaks, I need to have 4 more elements, right? And I can have 2 valleys here. Fine. Similarly, if I wanted 3 valleys, I could have done it like this. Right, and after I have these numbers, I can just put all these numbers in increasing order. So I don't get any peaks and any valleys here. Right, so here I can start with 2, 1, 3. Then I have, sorry, this should be, yeah, I can have 3 here. 3, 1, 2. Then I can have another smaller number here. Okay, if we want to have more valleys, what do we do? I guess as long as the total number of, as long as a plus b is less than n minus 2, this should be fine, right? So first of all, let's have this. So if a is less than equal to n minus 2, so 2 elements are removed, and then we are talking about these elements, right? And b is less than equal to n minus 2 plus 1 by 2, right? So here I guess the answer should be possible. Like if you look at it, then you know, if we want the number of peaks and the number of valleys, then the first 2 elements are removed, right? Then we have n minus 2 elements remaining. So now we can have one of them as, you know, okay, first of all, this overall sum should be less than equal to n minus 2, right? And a plus b is less than equal to n minus 2. So this should be the condition here. Right. Now if this is the condition, then one of them can be greater. Like if n minus 2 is odd, then a can be greater or b can be greater. Anything can be done here. Right. Okay. So first of all, we have to construct maximums. We can either construct maximums first of all and then minimums, or we can construct minimums first of all and then maximums. Right. So I guess we can try it out, like we can try out both ways, right? Whichever works. Helper, we have n comma a comma b. So helper 1 is basically where I'm constructing the maximums first of all, and then helper 2 is where I'm constructing the minimums first of all, right? So after this, I have right? So after this, I mean, we don't need this primes here anymore. Right, after this, there is one also a function called bool possible. Cool. So I have n comma okay, so if v at I is greater than v at I minus 1 and then v at I is greater than I plus 1, a minus minus, if v at I is less than v at I is less than v at I plus 1, then I have b minus minus. Right, this is fine, and now I have to construct here. So for helper 1 I have to construct the maximums first of all, so I can do this. So first I have inserted 1 here, then I equals to 2, I is less than, okay. Okay, so if a is greater than, okay, so I'm also constructing the maximums and I'm also constructing the minimums. No, this doesn't seem right. Okay, first of all, like if I'm doing this, let's say I increase it once and then I bring it here. Then if I increase it again, like if this is 1, this is 3, this is 2, then this is 4. So I already have 1 here and 1 here. If I don't want to do this, then I will have to have this. Right, so I can have 1, I can have 4, I can have 3, and then I can have 2. Right, this is what I would want then. No, but this won't work. I mean, I can also have this here. First of all, in order to have you know, if you want to have 2 maximums, then there has to be 1 minimum in between. Right. Similarly, when you come here, right, so this has to be something like mod of a minus b should be less than equal to 1. This is the condition that we require. Otherwise, this won't be possible. Like if we have more peaks, then we can do this, and then we can come down here. Right, because in order to have a peak, there have to be 2 elements this side, right? And in order to have a valley, like we can have something like this. So we have 2 peaks and 2 valleys, right? What if I have more valleys? If I have more valleys, I can, you know, just invert this whole array. Like if I have 1, I can replace it with n. If I have 2, I can replace it with n minus that, right? So yeah, I think this works, right? Okay, so this is, all of this is not required, right? Cool. So if a minus b is less than equal to 1 and a is less than equal to n minus 2 plus 1 by 2 and b is less than equal to, right? Because I mean this is pretty obvious. If this is the condition, then this is possible, otherwise it is not possible. Right, now I have to construct a vector. Okay, so for I is less than I plus, in fact I can have it like this. Smallest equals to 2, right? So while a is greater than 0 and b is greater than 0, so I have a peak, then I have a valley. I have a peak, then I have a valley. Okay, this is kind of difficult to implement. Okay, so then I can do a minus minus. So basically I'm constructing a peaks here. So when I'm constructing a peaks, I will be having a minus, okay, so this I don't need, right? So when I'm constructing a peaks, I will be having a minus 1 valleys, right? Okay. So here, like if I have a equals to 2, then I'm constructing 1, n, 2, n minus 1, I have 3. Or why not just construct it like this, 1, 3, 2, 4, sorry 5 and 4. And then when I get another peak here, let's say this is 6, sorry this is 7, then I have 5, 6 here, right? So after doing this, we will be having something like this, right? And after I'm done doing this, so now if I don't want a valley, then I have to go like this. And if I don't want a peak, I have to go like this. A and B can be equal as well, right? This is very hard to implement. Okay, I have 3 peaks here, 2 valleys. After this, if I need another valley, So right now I'm assuming that peaks is greater than valley, greater than or equal to. So if I need more peaks now, I need more valleys now, I can do this, right? If I don't need another valley, I can do this. Right. Okay, so let's just first of all assume that the peaks are bigger than the valleys, right? Bigger than or equal to. So I do, and what if I do something like this, that I have 1, n, then I have 2, then I have n minus 1, then I have 3. Will this value always be less? Like if I have 5, then I have 1, 5, 2, 4, 3. If I have 6, then I have 1, 5, 2, 4, 3, 6. No, but then this is not working out. Okay. Okay. So after doing this, I have something like this: 1, 3, 2, 5, 4. And now let's say these are the number of peaks that I've constructed. So first of all, I need to do this. I need to construct so many numbers here, right? So this can be for peaks, this can be for valleys. If valleys is greater, then I can just invert this whole thing, and that should do. So after this, now let's say I have 6, and then I have 7, and then I have 6. So now if I want to construct more valleys, let's say I need one more valley. If let's say they both are equal, then I can do this 8, 9, 10, so on up till, right? And if we don't need, then I can move it here, right? Then what I can do is, oh no, so if I need another valley, I can put it here. I can put all the numbers that are more and put it here. If I don't need another valley, then I can do this. This is n, n minus 1, so on. And if I don't need another valley, then I can do 5, 6, 7. No, but these values will be bigger already, right? So if these values are bigger, I will have to scale up all these values. Let's say 5 elements are remaining here. I have let's say 8, 9, 10. So I can make this as I need to make this as 1, right? Okay, let's say we need another valley. Now if Okay, so if A equals to B, then I can do this. For int I equals to biggest, big, I is less than n, I plus plus. In fact, this should be small, right? Like if I have, if I have 1, 3, 2, 5, 4, 7, 6, then I need 8, right? Yeah, then I need 8. So if this is the case, then I've already constructed my case, right? Yeah. If this is the case, then I'm already done. So then I can put all these numbers in decreasing order here, right? So first of all, I will have to scale them up by big, right? Yeah. Okay, can I put these numbers here? Will that work? Like if I have, all these numbers are bigger, right? Yeah. So if I scale it up, then all these numbers will become small. Okay, so first of all, I'll have to scale these numbers. I used to right. After this, I just insert all these numbers in decreasing order, right? Yeah. Greater than equal to big. V dot PB, I have I minus big plus 1. Yeah, let's now look at this. Okay, so I have 1, 3, 2, and 4. Fine. So I have one peak, one valley. This is fine. Then I have, then if you talk about this case, I have this 5, 7. So I'm having more peaks right now. 5, 7, 6, 8. Okay, this is coming out to be 7. So this was 5, 7, 6, 8, and this should have been, okay, so this was different, right? 1, 3, 2. This is plus 2 and plus 2. Okay, so now I have 7, 9. This was, okay, fine. 9, 8, 11, 10. How am I getting 11 here? One, 3, 2. One, 3, 2. Here I have 1, 3, 2, 5, and 4. So this is fine. After that, what do I need? I need big, right? So that is 7. But here I'm not putting big. Okay, this should have been I minus big. No, I plus big minus 1. So if this is 1, then I need to add 7 here. Okay. this won't work. What do I need to add? I need to scale these numbers to 1, 2, so on. Right, so I am subtracting how much here? I am subtracting big minus 1 here from every number. So these have to be scaled, right? So this is like the number of numbers remaining. Okay. So if there are 5 numbers, then I will have to scale them up by 5. Okay. Big is 7 here. This is just insane. So I have 1, 2, 3, 4, 5. Okay, 1, 3, 2, 5, 4. I have this. Then the next number is, next number should be small, right? It shouldn't be big, actually. Okay, fine. This should have been small. Like I have 4 and then I have 5. Similarly here now I have 6. Next number should be small only. So this should have been and then I have to scale them up. So this will be okay, this seems fine now. But there is just one more thing that we need to do. If peaks are greater than, okay, so we have 2, 3, right? So this seems fine. I have 2 peaks and then I have 1 valley here. Now if the number of, okay, so if A is less than B, this is what I do. Then I have to sort of just invert everything, right? I equals to n minus okay, so then I have, right, this seems fine. Okay, what if I have something like this, 6, 2, 2. So I have 1, 3, 2, 5, 4 and 6. This is fine. What if I have something like, 7, 2, 2? So then, oh, I am getting another 6 here. Okay, so initially I had 1, 3, 2, 5, 4. So now the number is 6, but then, okay. So here I will have to insert something else. These are the numbers that I have to insert, right? Okay, now I am getting 7 here. Small is 6 here. This had to be like this, right? So now this is fine. 2 peaks, 1, 2. And then I'm just inserting in an increasing order. let's say I had something like 3 peaks. I think this is also possible. So I have 1, 3, 2, 5, 4, 7, 6, right? And what if I have 3 valleys here? Then I have 7, 5, 6, 3, 4, 1, 2. This is fine. This is fine. Let's submit this. Wrong answer. Oh my god. This contest is turning out to be just insane. So if ABS of A minus B is less than equal to 1, A is less than equal to n minus 2 plus 1 by 2. 2 elements are discarded, then I'm just taking the peak value here. And B is less than equal to n minus 2 plus 1 by 2, okay. After that I'm saying big is this, small is this, construct is this. This is the number I'm constructing. This is what I'm taking. After that I'm doing this. Okay. Let's just do an assert statement here. Assert. So I have this function possible, right? Yeah. Okay. So I have, let's just consider some cases 5, 2, 2. Can we have this? Okay, this is somewhere it failed, okay. Hmm. 1, 3, 2. 5 minus 2 plus 1. So that's like 3 plus, so I can have 2 peaks, right? Yeah. And also A plus B should be less than equal to n minus 2. Right, this is what I wanted. I guess, yeah, that was the issue, I guess. Cool. So yeah, I have wasted quite a lot of time. My rank should be pretty bad right now. Yeah, pretty bad. Anyway, let's move to problem C. I don't know, this was somehow just very hard to implement. Anyway, n players are playing a game. There are 2 different maps in the game. For each player, we know his strength on each map. There are 2 different maps in the game, okay. For each player, we know his strength on each map, okay. When 2 players fight on a specific map, the player with the highest strength on that map always wins. No 2 players have the same strength on the same map. Okay. You're given, you are the game master and want to organize a tournament. There will be a total of n-1 battles. While there is more than 1 player in the tournament, choose any map and any 2 remaining players to fight to it. The player who loses will be eliminated from the tournament. Okay. In the end, exactly 1 player will remain and he is declared the winner of the tournament. For each player, determine if he can win the tournament. Okay, so you want to decide if this particular person can win. So, I mean, if you want to consider a person, then you will be considering him, on a map which has the highest, on which he has the highest value, right? And that should be greater than the lowest value. Okay, so now you want to consider every player and you want to consider their minimum. No, but if you're playing on a particular map, every person will be playing on that map. That is the condition. So for every player, you need to check if he can win with every other person or not. Also, what we can do is we can pair up the other numbers and, you know, and then choose this one at the end. That should be much better, right? Yeah. So, so let's say we consider the two players with maximum powers. We pair them up and then one of them loses. Okay, so if we have something like this, that I have two players, A and B. A has power 1 here and 2 here, and this has power, let's say 2 here and 3 here. So if I pair them up, this one will win. So, I mean, I need to have the lowest values, right? Let's say I sort of sort them in increasing order of their first value. Can I do that? And what do I have to print exactly? Okay, so I have to print the string. Right. Now, if we consider this whole vector, then I have something like this. I have two values here. 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 Right. Now, when you look at this person, you know, this person can win from all of these. Yes, this person can definitely win from all of these. On which map? Like if I'm considering the first map, then he can win from all of these on the first map itself because he has the higher power. Right. So let's just remove all of them. Now, if you look at these players, you will have to win from them as well, right? So how will you win here? Like the first map value is definitely less, right? And if I consider these and these, like can I pair them up first of all and then I consider only the biggest value? So this is less, then I consider the value with the highest, this second value. Okay, so I consider the highest value here, highest of the second value. If highest of the second value is greater than the maximum here, then I can win here, right? Yeah. Prefix and then I have vector int. So prefix is initially 0, I want the maximum, and suffix is like 1e9 because I want the, no, here also I want the maximum only, right? Yeah. Like the initial left half, I can use the left half and all of their values in the first map are less than the values in this first map in this right half. So I will have to choose the player with the highest value in the right in the second map, and I will have to look at these, right? So I have ff.ss. Okay. I equals to max of okay. Now I have a suffix at I equals to, why can't I just have n plus 1 here? Right, I need the maximum, right? So this can be 0. Max of v at I dot ff dot ss. Now all I need to do is this. If prefix of I is greater than suffix of I plus 1, answer at v at I dot ss equals to 1. So I have a 0 initially. I'm having 0, 0, 0, 1, and then here also I'm having 0, 0, 0, 1. Okay, so let's consider this debug v. Okay, so I have 11, 44, then I have 12, 21, then I have 20, 11, and then I have 20, 30, 21, 30. Okay, so here I can beat all the ones here, and then I have to beat all of them here. So this is fine, right? Yeah. Prefix at I is greater than suffix at I plus 1. So how is this an issue? Okay, this had to be SS, and this had to be, yeah, this had to be SS as well. So no, this had to be 0.ff.ss. Yeah, I think this is fine now. Yeah, let's submit it. Wrong answer. Okay, let's just see. So first of all, I am saying that if I consider this vector, I have two values here. I have sorted them by the first value. So if I'm standing at any place this, I can beat all these players, right? And talking about these players, the first map value here is greater than the first map value in this half. So I have to use the second value. So I will use this maximum second value here to beat all the players here. No, but if I have a first value here and I have a first value here, this person can beat all of them. That is the thing. Sorry, this person, last person can beat all of them. So if the last person can beat all of them, this has, let's say, of the second value as x. Like this power of this last person on the second map is, let's say, x. So if it is beating all these values, this x will never decrease, right? But let's say I decide that this person has to beat this person. Then what happens? I mean, the maximum is always increasing, right? So I don't need this suffix part. All I need is this v at n-1 dot ff dot ss. This is what I need, because I will only have to beat the last player. Okay, here it is somehow not working. So if there is just one person, okay. So if n equals to 1 or greater than equal to, let's take it. Now this should be fine. Okay, let's consider it again. Like if I talk about all these players here, I can use them. You know, I mean this person can beat all of them. So by beating all of them, instead of using this person, I can use any person here which has the maximum second, value, maximum value in the second map. And similarly, if you talk about here, this person can beat all of these values. Right? Yeah. So if this person can beat all of them, and I mean, if you look at this half and this half, you cannot be competing in the first, basically, the first map, because the first map value here are greater. So if you consider the second map, then for the second map, I can choose any value that has highest value here, and I can try to beat them here, right? So, and this person can beat all of them here. If I look at the person with the minimum value here, minimum second map value, this can beat all of them here. So he will be beating them in the second one, right? Yeah. So we should be picking up this one only. This is fine. .ff.ss, sorting, then taking the prefix maximum. So prefix at I equals to max of prefix at I minus 1, and this, fine. This is the answer. Now if prefix at I is greater than equal to v at n minus 1 dot I don't understand what is the issue here. Okay, that's a pretty huge negative delta right there. Either you beat in the first map or you beat in the second map. I can use what if I just have two values here? In the first map, this is the thing, and in the second map, the last value is always winning. One and two, 1 and 2. So I will be having something like this, right? I will be having 1, 2, and then I will be having 2, 1. First one is fine because the maximum is greater than the maximum here. For this one, what if I have something like 4 here? Segmentation fault. Second person is winning. So if I look at V, then I have 1, 2 and 0, 2, 4 and 1. Okay, what if I have something like this? Okay, now if you look at it, I can use this one to beat these ones, and then I can win from it. Similarly for this is fine. Or do I take the minimum one? How do I take the minimum one? So if you look at these players, then this person can beat all of them here. And then if you look at this one, okay, what if I have this? This person can beat this, and then this can beat this. Can I have a smaller value than this of the maximum? No, I can't. And here, like if you look at it, then all of these values. Prefix at I-1 b at I dot ff dot ss. Okay. So I have this as my vector. If I am considering this value, this person can beat all of them here. right? Yeah, it cannot beat all these players in the second map. So it can, no, not in the first map, it can only beat them in the second map. So how do you beat them in the second map? So in the second map, the minimum value can be this one only, because this person can beat all of them. If you are making this person win, then this second value is greater than this one. So the last one is fixed, fine. After that, all you have to do is you have to construct the prefix maximum here in the second value. Okay, when can we not win? Can there be a situation when we don't win only? So let's say I have so on the first map this person has 2, and on the second map this person has, let's say has 1. Okay, what about if this person has 3 on the second map? No, this is for the first person. These are the values 1 and 2. Then these are the second values. So the second player can always win here in the first map. Yeah. One, 3, 2, and 4. Okay. First person cannot win here. Prefix at I is greater than or equal to v at n-1.ff.ss. I don't know. I don't understand any issue that this should have. The person with the highest value in a particular map can win from all of them. Right. Now if this person can win from all of them, this person can only be beaten in the first map. Right. So which all people can beat him in the first map? That is the question. Right. Which all people can beat this person in the first map? The person with the highest value in the second map is winning. Or if you put it like this, the person with the highest value in the first map is always winning. But now which all players can beat this player? The highest value one. any player whose whose value in the second map is greater than this one can beat this player, right? So any person with greater than this value can beat, and I don't understand, this should be right. Int n values also seem to be fine according to me. Do I have to take long here? No, that is not required. Int v at i.ff.ff, v at i.ff.ss, and v at i.ss. So this seems to be fine. Then I've sorted all of them. Then I've taken a prefix maximum. So v at 0.ff.ss, v at i.ff.ss. So if prefix at I is greater than or equal to this, or how else can you beat them? Okay, this is wrong. This is wrong. I have made an issue. I have made a mistake here. Sorry, this had to be like this only. And this is fine. I hope I did not do this mistake here. Can I decrease the second maximum even further? Like if I have this value and this is, let's say, less, so I make it fight with this value. I take the maximum second value and I make it fight with these values. So I can further remove values by making this person fight with them. Right. This just seems to be very weird somehow. I am not sure what exactly is the issue. I mean, if it is printing extra characters, then this is a huge issue here. Because this might be an issue. Like I might be printing extra characters using that string. Okay. Now, I mean, there is some serious issue here. So if I'm at any index, it can beat all of the players here. Right. Now, when you talk about these values, the last person here, which has the highest of the first value, can beat all of them. Right. So this person can win from this only if the maximum is greater than this. Okay, so if I have this, I have sorted all these values. If I'm standing here, this person can win from all of them, for sure. Now, if I talk about these values, I cannot win from them in the first map. I cannot use any of them and win from them in the first map. So, if I look at this, let's not consider this last person, let's just consider these values here. Let's say I have some x value here, this can beat all of them here. All the values which have second, which have, maximum of second, which have second value less than this. So this person can, anybody here can beat all of the people here such that they have a smaller value, right? So let's say I have prefix maximum here. So this can beat all the values which have these values. After that, let's say some values are left. This could be left, this could be left. So in this, I can't really do much. Like I can make these people fight amongst themselves and or if you look at this, this person can remove all of them. If I can beat this person can remove all of them. So if I can beat this last person can remove all of these people, right? Yeah. When else can a person win? Like if I have 3, I have 1, 2, 3, I have 3, 2, 3, 1, let's say. So I have, let's also debug prefix. I have 1, 2, then I have 2, 3, then I have 3, 1. So this person can win from both of them. Okay. Okay, so if there is a person who is winning in both of these maps, then he's always the winner. If let's say this person is not winning in one of the maps, then all the people that are beating this person in that map do stand a chance. Okay, let's say I have 1, 2, 3. And this last person is winning in the first map, it is not winning in the second map. So let's say I have 2, 3, or 1, 3, 2. This first person can never win, right? If I just remove all the values where you are winning in neither of them, then you are just done. I don't know, this is just insane. This is turning out to be one hell of a contest. Very bad. Why am I not getting this? Two different maps in the game. For each player, we know his strength on each map. When two players fight on a specific map, the player with the highest strength on that map always wins. No two players are the same strength on the same map. You're the game master and want to organize a tournament. There will be a total of n-1 battles. While there is more than one player in the tournament, choose any map and any two remaining players to fight to it. On it. Okay. I think as long as you don't have the minimum in any of them, you can win. I don't know, this just seems really weird. Okay, now if v at i.ff.ff equals to max1 and then v.ff.ss, and I don't know, this is a very weird approach, but let's just see. Also, let me turn on the charging here. I don't know how this is working. This is just insane. I haven't applied any logic first of all here. This is just insane. I don't know how this is working.